Okay, everyone, welcome. We'll get started. Thank you all for being here. My name is Dave Hondula. I'm an assistant professor in the school, and thanks for joining us for the first of this season's colloquium in the School of Geographical Sciences and Urban Planning. We'll introduce our distinguished speaker in just a moment, but a few updates and announcements, especially for the folks in the school here. One, you might notice that I'm speaking into this microphone, which is not amplifying my sound whatsoever. But it is broadcasting our colloquium to the world. Our colloquium will be live web streamed moving forward, which we're very excited about. And we're especially excited that you all will still be here to participate, despite the availability of the web stream. I'd also like to thank many folks who have helped with the logistics. We have grad students Zach and Maddie. Maddie is somewhere, perhaps not here today. They've been helping with a lot of the behind the scenes work, as well as Peter Kedron. Peter, hello, Peter. Yes, and of course the front desk staff and Nick Ray. Thanks to all of them with the many logistics that it takes to bring such wonderful folks to be here with us. We'd ask that you please sign in on your way out. Zach is holding up the sign-in sheet here. This helps keep Nick happy with our accounting purposes. Thank you for doing so. And while you're signing in, please be sure to help yourself to some of the refreshments we have today. We are very pleased to welcome Andrew Curtis as our first speaker for this spring. Welcome, Andrew. Andrew joins us from Kent State University in Ohio, where he's the co-director of the GIS Health and Hazards Lab. He has a distinguished and accomplished record that I'm sure you have all been reviewing online. But to summarize his record, he has a wide range of engagement with the public sector in topics that broadly span health, hazards, and spatial analysis. And I think he interestingly touches on a number of areas of relevance to this school, including his work in disaster response. And this spans work related to Hurricane Katrina, some of the major tornado outbreaks, and others that I suspect we'll hear a bit about. His CV will need to be updated soon for two reasons. One, starting this August, he'll be moving to Case Western Medical School to begin an appointment as professor of epidemiology. Congratulations. But even more notably, I believe you have now set the attendance record for Geographical Sciences Colloquium at ASU. This is the most crowded the room has been. So with that, let's welcome Andrew Curtis. Thanks so much.
Thank you. I also want to sort of add my thanks for the people who've looked after me the last couple of days. It's been really, really wonderful. If I am a bit slow moving it about, I'm sore. Stuart took me on a 10-mile hike up a mountain yesterday, followed by a round of golf. And so I've now, all my muscles are aching. But thanks very much for inviting me for this talk. And I'm going to cover quite a few different topics here. I'm not really going to focus on any one sort of topical area. I'm really going to be looking at the way I work in a variety of both hazard and health arenas and the different technologies and approaches we bring to these. Well, in the health arena, which is really where I sort of focus now, the spatial appreciation is certainly there. The APHA, American Public Health Association, their national meeting a few years ago had as a theme healthography. That, as it says, place matters. The understanding of the geography around health landscapes is really important. And what I've got up here are two maps I've been involved with, and then a third one which is sort of nationally famous. This one here is a map from Skid Row in Los Angeles. It's literally, when we talk about a pin map, this is a pin map. It's a map on the wall of a non-profit health unit, and these are the locations of all the Narcan reversals. Narcan is the drug you give to somebody who is overdosing. So all the Narcan reversals within Skid Row. This is the only data set they have that is spatial. So we digitized this to actually turn it into, a data layer we could use. But I thought it's interesting. They understand the importance of space, but they've got no real way of dealing with it. The other map on the far side was again in Los Angeles. It was a clinician working on tuberculosis and TB. And again, there was this understanding that space matters. In this case, it was actually one of those old road atlases with lots of sticky notes in it where different people came from for one cluster around a convenience store. And of course, you've all heard about the lead exposure in Flint, Michigan. It's a really important topic in terms of environmental exposure. But the cool spatial aspect about this is the pediatrics doctor who initially suspected something was happening made her own map of where these high concentrations of lead exposure were, and was ridiculed by us, as spatial scientists. Eventually, though, she was proved right, and then went through and published proper papers on this. So I'm going to touch on a lot of different topical areas, but these are really the three themes I'm going to be really framing my talk around. The first is, do we have the right data to try and respond to these situations? The second is looking at what I call data poor environments, areas where we don't have a lot of data. How can we actually rectify that problem? And the third is it's a big push within the geographical sciences, and that is the importance of context. So there's two other aspects which come into this talk as well. The first is what I call the scale of intervention, and that is being able to do work at a geographic scale that makes sense to the people who then go out and try and rectify the problem. Whether that is epidemiologists, or it could be clinicians, or it could be people working in county, state disaster science units. But it's working with data and producing results that make sense for intervention. And I'm going to show several pieces of new software we've developed to help this. I mean, this is great. We're now at a really new phase of being able to use programming to then do the things GIS is just a little bit too clunky to achieve. A bit of a background about me. I've been at a few different universities. When I was at Louisiana State University, I was the director of the World Health Organization Collaborating Center for Remote Sensing and GIS in Public Health. Really long-winded title, and we had multiple projects on the go. But then in 2005, when Hurricane Katrina hit, my lab, along with a few other GIS labs on campus, provided the geospatial response. So the equipment, I always remember we had a truck in the rain, took our plotter, put it on the back of a truck, tarp over the top of it, drove it to the OC so they'd have a couple of different plotters working as we went through the response. But my students, the different faculty from LSU, we all produced 24/7 spatial response to this disaster. It was interesting. I had a conversation earlier today with somebody, I can't remember who now, sorry, talking about the data that was generated in this, this particular event. Because I was there as an academic and not one of the professionals, I was just saving data whenever I could. I mean, including 911 calls, including animal rescue data. Whatever data we had, we were just storing it. Then after Katrina, after we'd gone through Katrina, followed by Rita, we had to start putting the pieces together. Well, one of those pieces, because I've been working on infant mortality, been working on disparities in terms of birth outcomes, was we've got an influx of mothers, influx of pregnant women coming into Baton Rouge. What are we going to do? And so this graphic here was the planning map. A group of us got into a room from the Office of Public Health, myself, various nonprofits. What agencies, what organizations do we need to get to the table to start going to the different relief centers we're opening up? So it was using, in a real world sense, all our different data inputs to try and figure out a solution to this one problem. From this event as well, I was asked to go to Maynooth in Ireland, as Stuart invited me, to talk about the Katrina response. And when I was there, I actually talked to one of the scientists who had developed a spatial video approach, primarily for transportation work. Now, spatial video basically means a video with a GPS attached to it in some way. In this initial type of camera system, it was a camcorder with an external GPS, and the two matched together using an audio signal. But I took a kit back and I then went and mapped the damage in the low 9th ward. So we've got almost a complete spatial video damage set from the low 9th ward, which had the most damage within Hurricane Katrina. And that was really the beginning part of the research that I carried on with. So, first part, do we have the right data? Well, even with traditional health analysis, at that scale of intervention, at the finest scale, there are issues we have to think about which we often conveniently don't talk about. Two here, mobility and activity space. So mobility. This nice bird's nest here is actually one of my PhD students working with a blood-led clinic at Akron Children's Hospital over a 3-year period. All the families that had gone through it, all their residencies. it became immediately obvious how mobile this at-risk population was, bouncing from house to house to house. And so when you do a cross-sectional analysis, one single address, what are you really capturing when you do that type of analysis? So this is important in terms of lead exposure, but it's also important for all other health outcomes as well. There's a lot of mobility, and the mobility increases actually with more at-risk populations. The other graphic is actually when we first started to try and capture mobility issues. This was a database system we put together for a non-profit organization looking at African American infant mortality. So we started to tease out these sort of changes in address a long time ago. There's different ways to think about mobility within these data sets, and I've just got the two main ones here. The first on this side, in this graphic we show one family over a 3-year period, all the different locations they have lived. So they've bounced from house to house to house. The other graphic looks at it in a slightly different way. All the different families that have gone through the same house. Different health problems actually resonate with both of these approaches. For example, lead exposure. Lead exposure is actually a reactive system. If a child has high blood lead levels, then you have to investigate. But if that family moves away from that house, the investigation is dead. So if that house is causing a problem and multiple families are moving through it, obviously you can see there's going to be an issue involved. Another problem is activity space. The data we use, the geocoded data, is the residential address. Well, for a lot of individuals, obviously their daily sort of activity is more important dependent on the disease that we're investigating. This is from Los Angeles, and what you see in the three-dimensional graphic is the number of teenage chlamydia and gonorrhea cases by parcel. Now these parcels could be apartment complexes, single buildings, but these are the residential address of teenagers. They're probably not getting chlamydia and gonorrhea from the residential address because it's the parent's address. So if you really want to start looking at what is going on in these hotspot areas, you need to get a sense of the activity space. Where are these teens actually sort of meeting? So these are some of the issues which we work with. One of the problems in terms of mobility is the data is collected in hospital records. It's in their electronic medical systems. But because those systems are primarily designed to contact people, it's not easy to get at. It's not easy to extract. Well, anyway, developing new approaches to try and sort of rectify some of these data gaps, one of which was that spatial video system which I mentioned that we did with Hurricane Katrina. So this is one of the current systems we use, which is a contour camera. It's a sports camera that has a GPS inside it. There's actually a few other ones, a police body-worn camera as well. This allows us to go into environments and then capture data we can use as a digitizing source. Just as a couple of examples, and I had some conversations earlier today about the impacts on neighborhoods in terms of ecology, in terms of changing landscape. This is in Akron. It's an NIJ-funded project, and for this particular parcel, you can see how it has changed over 6 time periods. So by going back through these neighborhoods, you get a sense of the amount of change that happens. In this particular project, we were looking at lead exposure, but we wanted to make it more proactive. Now, there are sort of visual signals in terms of lead exposure, one of which is what we call alligator peeling paint, which tends to be lead paint under weathering. It has this sort of, at the top of the house, you can see there's this sort of flaking effect. So we could potentially use this to start to identify properties which are likely or possibly going to be problematic for families moving through them. Another example associated with violence, gang activity. The map you see is the amount of gunshots around a school in Youngstown. Now, these locations of gunshots come from the shot spotter system, which you have in Youngstown, which is actually an audio triangulation system. Gunshot goes off, different microphones triangulate where the gunshot is, and you know, okay, there's been a gunshot at this place. But you don't have other data layers, other environmental data layers that go with it. So by the neighborhood assessments we were doing, you could look at the state of property, where the properties are abandoned, and it gives you another data layer to analyze with your shot spotter data. And then, of course, you can identify other signatures which are important, such as gang tags. This is MX13, which is one of the big Latino gangs, especially. It's actually throughout the United States, but especially in the Southern California area. So shifting focus a little bit, that's the first part in terms of how do we start to create new data. Can we take these systems and these approaches and put them into really data-challenged environments? And so in some of the overseas locations we've been working with the same spatial video approaches, we've looked at both water access, various vector-borne diseases, and different enteric diseases such as dysentery or cholera. Here, for example, this is work that was done in Tanzania, and we were looking at the pathway from a public well to the residence of where the person lives, and then mapping out all the risk factors that could potentially lead to water contamination along that path. Now, although we could then sort of map these out, what I want to draw your attention to is the yellow line shows where that GPS path actually went. So in these environments, they are notoriously poor for GPS use. Not only it's the latitude, but it's the close packed corridors, overhanging roofs, a lot of reflective surfaces all mess with the GPS signal. Not particularly in this one, but also in environments like in Kenya, it's also dangerous, and so the camera is often hidden by our collaborators. That also messes with the signal. So what you see here is the correction. The red line is the corrected GPS path. And this was done by using the video imagery, not really overhead in this sense, but the video imagery to really sort of follow the path and then correct exactly where this individual had been walking. This is the informal settlement called Mathare in Nairobi, and you can sort of see this same data problem. This bird's nest here are the GPS paths from all the data we've collected over about a 3-year period. This is the corrected path where we've now sort of gone in and manually corrected each of these GPS locations. And this has led to some interesting analysis in terms of how much error is across this neighborhood. Can we start to identify those sort of fallout points where we're always going to get issues in terms of data quality? But we wanted to go further with this. And these are a couple of the first pieces of software we developed for this. The first is the camera player, just here. So the camera player takes video, spatial video, from a variety of different cameras. It's not camera specific. It shows the video and it also displays the GPS path. You can also do a little bit of mapping with it, but you can extract the GPS from it. The reason that's important is, unfortunately, a lot of the technology we use, like the contour camera, is in small companies which often go under. So the software that is used to support these technologies, you can't be reliant on. So we have to actually start developing our own. On the right-hand side is another simple piece of software we developed to actually make this a far more universal system for our collaborators. By taking the video, uploading it to YouTube, then matching it by timestamp to the path, we in effect create the same spatial video, but now with a really small data footprint. So you no longer need access to the actual video itself, which is quite a data hog, but you can still do the same work. Putting those two together, if we now use this and this to correct the GPS path, we can use this system to extract the new GPS path, put it back into our camera player, and in effect now create this where it's a spatial video path. So the GPS is linked back to the video, and we can now actually use it to know exactly where we are on the frames that we've captured. So that's actually an important sort of tool to use in these environments. And to give you a little sense of one of the biggest projects that we've been working on, this is water quality within Haiti. We've been working there the last 3 years. It's a 5-year NIH-funded project. A couple of interesting things about this. This whole peninsula did not exist 10 years ago. It's actually formed on compacted trash. Even now the Google imagery is not big enough. So we have trash which is continually being dumped. As it's dumped, settles down, buildings are built on it, and so the peninsula extends outwards. Well, we have been collecting water quality fecal coliform counts. This is a collaboration with both Haiti and also the University of Florida. in multiple water access points and also drainage channels. So we have the epidemiological data in terms of fecal coliform, potential sort of contamination of these water sources. But what we wanted to do is add in that spatial video to give us the microenvironmental context in terms of what was happening around each of these water points. And without getting into this graphic too much, the black line basically shows the amount of contamination, but then these others are the environment around, the amount of standing water, the amount of mud, the amount of potential contamination that could explain these fecal coliform counts. Another important sort of aspect from this, at the top there, you sort of see how the same water point has changed within this data collection period. It's gone from a cistern in the ground, which is more susceptible to overland flow from drainage channels, especially during sort of rainy season, to a tap, which although it's illegally tapped into the underground pipes, actually has less chance of exposure actually at the point of getting to the water. Well, there's so many pieces going on with these data sets. We had to develop a new piece of software that would allow us to explore the data spatially. So this graphic really does not show the power of this. I love this particular piece of software. Each one of these points is just a water testing location. Click on any one of those, it's going to give you the fecal coliform count for that location in comparison to all the others that get collected at that particular time point. You also see its fecal coliform count compared to its own history. So you see how it stacks up against its own sort of time frame, and also how it fits in with the rest of the water points on that particular month collection. Spatially, we show the same information, but also spatially we show the amount of environmental contamination, the amount of standing water and mud as well. So this allows us to sort of really play around to see where you get variations occurring and what are those sort of micro variations between different water points. But even with all of this, if you don't really look at the context, then you're missing something out. So we can be testing water quality at these various water points, but if the kids are then playing in this type of drainage channel, which is going to have human feces in it, you're missing a huge part of the contamination potential for the families living in this environment. So that's our next step, is to really start to beef up the contextual side of our analysis. One piece of software I'm not actually going to show here, which I think is really important, it's from an NSF-funded project we're working on. It was how to compress video data. The video system we're using is a real data hog. In effect, it's about almost 4 gigabytes for 40 minutes, so 1 gigabyte for every 10 minutes. If you're in the field, if you're in Haiti collecting data, you literally have to transport this. You know, sort of somebody brings a hard drive back every couple of months. So we've been developing a new compression system, and the guys in computer science who I work with have been going through reducing the visual quality, bringing it down. Then one day, because I'd worked on the data set from Ireland, I thought, well, you know, we used to have a frame capture with that data where for every second it was 6 frames. Now we're dealing with high definition quality data, it's actually 30 frames per second. So instead of reducing the quality of the video, extract out most of the frames. If we're using this as a digital source, you don't need any more than 4 or 5 frames per second. And that massively reduced down the data footprint, and now we can actually transfer data sort of more to through the internet than we were previously. So the importance of context. So context gives us the ability to enrich existing data and help interpret our findings as well. This is Mei-Po Kwon's work on the uncertain geographic context problem, and you know, I'm a great fan of the contextual work she has done. From our perspective, the way we have previously collected contextual data, one approach has been sketch maps. Now, sketch maps, we've used these in a variety of our studies. People who know what they're talking about, residents, professionals, identify locations on the map. One of the challenges has been, how do you standardize this type of data into a spatial layer you can use in the GIS? And so we have done some of that standardization. This was actually published in Environment Planning B, We've also developed iPad apps where we can do this in the digital realm, but it's still not brilliant because you've got that sort of barrier of technology with the populations you're working with. But at the moment, this week actually, there is a homeless census in Tulare County where the health department is using sketch maps the first time in association with their other servers they're using. So it's the first time space is really being included in the data acquisition for the homeless. But the work that I have basically sort of been doing involves the spatial video geonarrative. In a sort of nutshell, what this is, it's spatial video, but you add in a narration at the same time. So while you're collecting visual evidence, you're also getting that contextual interpretation at the same point. So some of this is a general one neighborhood we've collected in Akron as part of the NRJ project. You collect police officers' interpretations, which is the word cloud on your left, or community sort of perspectives, which is the word cloud on the right. So at the beginning, this is what we were doing, variations in these perspectives for this one space. We have gone on to look at a lot of data-challenged, marginalized populations, populations where we don't have a lot of spatial insight into terms of what's going on. Here we've got sex workers, for example, in Los Angeles, their locations, but also their narration of what is it like to be a sex worker in these spaces. In this case, it's the homeless within Skid Row, another marginalized population, and so multiple homeless narratives, multiple providers working with them. You start to get sort of an insight in terms of both what it's like to live there, but then sort of more tangible results that the health department can work on. So for example, these locations are important. This is a corner where a lot of drug dealing happens. This alleyway is where a lot of people will overdose in. Another drug dealing location beneath this pink bush. But outside of the types of drugs, well actually, so the different types of drugs are identified in this landscape, one of which was spice. Spice is a synthetic drug, which this was before it really started causing problems. And so the homeless were saying we're starting to see more and more of this being used. And so about a year later, there was a spice overdose, sort of cluster of overdoses in the locations that we had actually sort of mapped out previously using this narrative. As I sort of said previously, gang tags are also another aspect you can capture for the built environment, but if you get the narration that goes with them, you start to sort of get a sense of the change that is happening within the neighborhood. Here you see one of the gangs within Los Angeles, the Quattro Flats. It's in East LA, Boyle Heights. And so this was around a public housing unit, and the ex-gang member who was out with us on the narration was saying this was a real problem because although gangs have been suppressed in the area for a long time, these markers, these tags were starting to show that the gang itself was starting to re-emerge. So you get a sense of not only where these locations are, but also the impact they're having on the population. Outside of the marginalized populations, probably the biggest area we have worked with in terms of using spatial video geonarratives are overdoses. In different environments, looking at the causations and the patterns associated with overdoses. So in Portage County, which is the county where Kent is, you've got multiple towns, all varying sizes, and each has overdose problems, but they're all different. There's different locations, there's different pathways to overdoses. So for example, parking lots tend to be a key location because in parking lots you now meet your drug, the person providing you with the drugs. Not very often do you go to a house anymore, you go to a big open space where two cars can pull up and there's a drug exchange. Quite often these are actually within the parking lot of a fast food location. You then take the drugs, go into the bathroom of the fast food location, you'll overdose there, partly because if you take the drugs and overdose, someone's going to discover you and they're actually going to save you. So we started to identify where these locations were, as well as other sort of micro-geographies involved with each of the communities of what was happening around drug use and overdoses. This is another piece of software. It's very similar to the one we did for the GPS correction. This time you can actually have multiple video streams. Again, it's YouTube, so the left-hand channel, right-hand channel, you could have a center channel as well. At the bottom, you've got the GPS path that's synced together. you can now put the geonarrative on top of it as well, the textual information, and this very small footprint was used by the Chief of Police for Ravenna to take it to his mayor's office so you could actually show her what was happening in the town. Yes, we know this, but now you've got a tool to be able to actually get this message across. This is what we're facing on the street. But to do this, we had to create this software. And I'm just going to go through this a little bit. Over on this side, you bring in your video, you bring in the narration, which has now been transcribed, and you've got a time sort of match where you bring the two together. Once they're synced up, you've generated a map of locations. It's actually each one of these pins is the beginning point of that comment. The comments are over here. If you click on this comment, it will show on the map and vice versa. Down here, you've actually got various keywords you can add in. So if you have an interest in overdoses, you could put overdose in here. Once you add it into the system, it's going to identify all the comments where overdoses are mentioned and also visualize them on the map. At the same time, it's going to generate a word cloud so you can start to look for co-occurring words. If you're interested in overdoses, it may very well be that bathroom pops up. And so by going to those co-occurring words, you can add this into the search engine here and start to sort of go backwards and forwards with your searching routine. When you're happy with this, you can export the data as a shapefile, a KML, if you're working with collaborators, because they can then sort of see the output in terms of Google Earth. But this word mapper tool allows us to take these narratives and start to investigate them. And this opens up a lot of avenues of research. So for example, this was a series of narratives we collected in Cambodia looking at genocide. And so actually these narratives were collected, just to give you a little bit of a background, in Phnom Penh, when the Khmer Rouge first took over the city, they actually mass evacuated everybody from the city. And so these narratives were actually with individuals who were evacuated, and we started at their home and followed their path outwards. And they talked about what it was like all the way along that path out of the city. From those narratives, we could then build up this picture of the evacuation of Phnom Penh. What's interesting about this is in a parallel set of research in the digital humanities, so those folks who are sort of using GIS and spatial approaches to try and look at things like genocide or history, one of the criticisms, and it's a justified criticism they have, is when you have different media sources, a GIS is just too clunky to deal with it adequately. You have space, you have attribute columns. I mean, ultimately that's what the GIS is. So using this approach is far more fluid, which is what they want in terms of you don't know what your question is. You want to be able to go backwards and forwards from narrative to video to map back to narrative to really see how these situations work. It allows you to learn using the data you have at your fingertips. And so we have sort of taken this approach in different directions. This is an analysis of, for one part of Akron, drug associations and violence. What you see at the top here is an analysis of the sketch maps we collected, and you can see C there is a sort of an F shape. This is reflected in our analysis of the word mapper data that came out of that. So there is a sort of commonality between the two. And when we put them together and also add on more traditional data, like police call for services, you can start to see where these geographies overlap. What's important though is that although you may identify this F from these different types of data, it is the geonarratives that allow you to then click on any one of those locations and see what is said about it. So you can contextualize, not only identify these hotspot areas, but get the insights of what is actually happening there. And I think even more interestingly, it's those spaces, the hidden hotspots. If you think about it, calls for service, when the police get called out, it's reliant on two things. Are there public around? Do the police actually are they involved in patrols in those areas? If not, the very worst things like bodies, etc., are going to become part of the record. But otherwise, you're not going to get people sort of calling in to say there's drug activity or violence happening. So from these narratives, you're going to start to identify the data areas that you do not get from more traditional data sources. So where do we go from here? What are the next steps, the next sort of research directions we take in this? We've developed a multi-narrative tool. Now what this is, it takes the word mapper document, so basically those, the word, after you've gone through word mapper, you've now got a JSON file. These JSON files, or the KML files, can all be put into this one single piece of software. So we've got about 1,000 different narratives from different environments, and you can do your search over all of them. So you can now start to look for patterns within the narratives irrespective of location. So it gives you the chance to start to look for patterns across different geographies, across different research topical areas. And it has much of the same other features we had with the initial word mapper, the co-occurring word tool, the mapping ability, and the ability to then extract out shapefiles or KML files. The slight variation at the bottom here is that the comment, which actually identifies the keyword where it is, you can actually sort of bump it up to a couple of comments before and after, just so you get the contextualization around where that keyword actually happens. We're also, well, at least my students are interested in the machine learning aspect of this as well, in terms of can you identify spatial text from these narratives. So there are there's more than three, but three basic types of data that come from the narrative. Spatially specific, where a location where you're at is described. Spatially fuzzy, which means you're in the general vicinity, so the person is talking in general terms about this area. And then spatially inspired. These narratives really give you insight into processes which may not be spatial in themselves. Added to that, you've got display spatial mentions. You could be talking about, like here, a particular hotel and what is happening, but it's actually somewhere off and away. Or it could be further insight on something you've passed previously. At the moment, it's very much a manual process to go through and identify these spatial locations, but we've been working on, can we set algorithms running to identify these? I believe this is also a wonderful data set for those interested in sentiment analysis and actually starting to get emotional constructs within the language as well. Instead of using something like tweets, which is not that rich a data set really, this gives you so much more information that you could start to train your algorithms on. Working with computer science, we've got a couple of different projects on the go. This one actually combines different video together and allows us to start to cut video for the same location over multiple time periods. So it's a nice tool to actually look at the same space across different data collection periods. A counter tool to this, what my PhD student has just developed, which is really nice, is he sets a miner or a browser going through the whole server to identify all spatial video using the camera player, which he also developed, to create JSON files of every single spatial video. Then when you have a map interface, if you draw a box around any location, any JSON file that intersects that box will be identified in terms of its location on your server, and also within it, it will give you the time frame of exactly where you go to on that particular video to see where it was. So if you want to look at sort of post-disaster assessments, which we're working with a group on our Joplin tornado work, this is an easy way to say, you're interested in this road, set that sort of crawler running, and we'll tell you exactly what we've got and for what time periods. So that's a nice way to deal with these data. This particular piece of software brings multiple textual data layers together and sort of puts them on the same map. One of the problems when you're working with topics like overdoses is you don't have data sets where overdose is a nice, neat attribute column. Quite often, that discussion will be buried within the attribute structure. It could be 2 or 3 layers below in terms of the way notations are made. So with this, you can identify different input data layers. As long as you've got coordinates that will allow you to map it, you can then set keywords running to identify if that keyword is found anywhere in the data structure that is connected to that one particular location. So that actually is a lot more powerful than the GIS. When you think about it, GIS, coordinates, simple attribute structure, this allows you to really start to sort of dig down into the other textual layers. Then finally, this paper came out of the work in Hurricane Katrina. It was spatial confidentiality, how we can actually put up if we sort of re-engineer information from a digital map, so take a newspaper map, scan it, register it, digitize out key locations, in this case mortalities. We went into the field to identify those houses, and it's one of those gold standard papers showing the importance of spatial confidentiality, or the risks involved in terms of mapping and GIS work. Well, an idea I've had for a long time, but now we've actually coded it out, is a way to counter this. And it's a very simple approach, and that is, if you work with a unit like a hospital, they can take a data set which has coordinates, no other sort of identifiable information, no addresses, social security numbers, but you've got coordinates and you've got other attribute data that goes with it. Put it through this system we've developed, it will generate new coordinates for those coordinates somewhere else on the Earth, but everything is maintained. The proximity to each other, the distances between each, so we can then run whatever analysis we want on that data set, re-put it back through the system, and they will then sort of get it turned back into an output which actually makes sense to them in their host area. But we don't know where those coordinates come from. It also means that we can then have a discussion with them to help interpret those outputs. So this is a really quite straightforward way of dealing with confidentiality, and we've now developed it. We run it through different types of analysis to see how it works, and we've got a couple of different hospitals which are ready to start working with us on using this as a way to start collaborations with academics. So I think that's about it. There's a bunch of different acknowledgements to people, but too many people for me to say. There's been a lot of great collaborators, I think, and questions?
Thank you very much, Andrew. For the millions who have tuned in around the web, please use the microphone to ask your question.
Hi, Mike.
Have you explored crowdsourcing? For example, cyclists are very avid. Potential crowdsourcers, students walking. In other words, to upload the video and the narrative and absorb the data.
Actually, there's two responses to that. The first is in terms of crowdsourcing, the online mapper where you actually link it to the YouTube and people can digitize. That actually means this could be used as a crowdsourcing tool if you want people to sort of correct GPS paths. They're perfectly able to do this. So that's one part of that. But it's interesting you talk about cyclists, because I mean there are many projects that I haven't talked about. One of them was actually to put these cameras onto cycles, then have people, which we did, they basically sort of went along all the bike paths. Because if you go to a doctor and the doctor sort of says to you, you need to exercise more, how about getting on your bike? You then go to the local city and they give you a bike map. You're probably putting your life more at risk on some of those bike paths than you are actually doing nothing whatsoever. So we could use this system to then create basically a sort of risk layer of which bike paths would you want to go on if you are a sort of novice cyclist. And this included the traffic, sort of the amount of traffic, how close it was to you, the amount of degradation of the road surface within the bike lane, but all of these could be captured from the video. So yeah, we've actually looked at that. And also we've done this, I use this within all my classes as a final project. So several of the students have taken it out into like parks. It's a way for them to get involved in the actual data collection process. But that's one of the common things they do, is take it to local parks to look at the quality of the parks, look at lighting, look at vegetation overgrowth in certain built environment areas. But yeah.
Thank you so much for the great talk. I have two questions. The first one, when you do the mobility analysis of blood, did you consider the resident time for each location?
That's in there.
Okay.
That's in. So you can look at that if you want to. I didn't actually show it here, but yeah.
Yeah.
Well, it's sort of in there. I mean, you've got the residents when they interact with the hospital. you don't know when they left. You don't know how long they stayed at that place. So, but you do have a time frame that goes along with each of those residences.
Yeah, thank you. So the second question is, how did you extract the information from a video? Any method like image recognitions, CNN, or machine learning to get the information from the image?
Yeah, I mean, in terms of as a digitizing source at the moment, it's manual, but that's one of the things we've started to actually look at is how to actually use image recognition to start. If one of the problems, and this is a real challenge, is that you could have a car going in different directions, you could have different distances away. So I think, and this is what I keep championing again, based on the work we did with the Irish unit, is to actually start using frame captures and then using each individual image and to see where you have change on those. But we started to explore it. You know, is it possible to do? I think the software and the technical ability of the people we're working with are now at a level where it should be feasible to do something. Yeah.
My question is that do you have any concerns about privacy?
Sure. Yeah, I mean, every one of these, we have IRB. We don't publish anything which is, you know, sort of basically showing individual data. With narratives, it's possible that, I mean, actually, I know more about the confidentiality risks than the IRB board does. And so, you know, you don't want to open up that particular can of worms in terms of what could go wrong here. But we're very sensitive to it. I mean, people can talk about individual sort of data in their narratives, not only just themselves, but others out, you know, on the path. I mean, you get a lot of that. So you have to be sensitive in terms of what you represent, you know, how you actually deal with the data. All the narratives are, one of the things we do say that we use when we go through IRB, all the narratives are anonymous. So we will get basic information like sort of sex, approximate age, if the person is homeless or if they are a professional worker, but we don't actually have anything else attached to them as an individual. But yes, it's always a concern with any work we do at that fine scale of data aggregation.
We have time for a few more questions.
So when you're collaborating, like the narrative, are they essentially like individual interviews with people that are in the area, or is it people that are familiar with the area going around with somebody that's part of your team?
It's what happens is we have actually worked with community groups where they go and do it all themselves without our participation at all, and we just get the data back. So it has that degree of flexibility. Traditionally, what we do is there'll be one or two researchers in the car, one driving, one making sure the equipment going on, both asking questions, and then somebody who lives in that community or somebody who works in that community just talking about the environment. They've got an idea of what we are interested in, but I think one of the benefits of this is you want to have as much flexibility in terms of let the individual talk about whatever they want to talk about, because you don't know what is good. And they're going to say things that you hadn't even thought about. And so then the researchers basically maybe ask sort of supporting or qualifying questions. Probably the most common thing we do is actually just put in little spatial sort of cues, like, oh, you mean the house on the left? Because although they're talking about something, not always do they actually sort of identify exactly where it is they are focusing their attention on.
And when you showed the pictures of like the police calls or the drug calls, is that just based off of the location of the cell phone that made the initial call, or how is that? That's
the response call for the police data. So that's basically the location that the police officer is actually told to go to. So what happens typically is a call will come in. It doesn't always have to be a call. There are a couple of the mechanisms, but most of them are going to calls that come in to the dispatch desk. They'll take some basic information, including the location of where the officer should go to. That record is what generates the call for service data. Yep.
Perhaps one more.
Hi. So I guess I have two questions, but hopefully one of them short.
Sure.
One is if you had explored the use of accelerometers as a way of tracking that GPS path. And then the other one was I guess maybe answer that question.
Actually, sort of biometric sensors in general are really cool, and I would love to. I'd actually love to sort of try using a biometric sensor that will get an emotional response, because we do get emotional response within the narrative in terms of what is said and even the way it's said. It would be interesting to sort of actually see the impact it has on an individual in terms of, pulse rate or, some of the other mechanisms you have. I mean, that's getting into a little bit more invasive than we've previously been dealing with. But many of these sort of basically biomedical sensors now have the ability through the timestamp to sync up to GPS. So, I mean, it's just one natural additional sensor to the data array we already have.
Which is pretty good lead in my next question. When you had the confidentiality sort of spatial encryption approach, wonder if you could expand a little bit more on that. For example, like in a road network, I could imagine somebody just trying to like match that up with an existing road network.
Yeah,
to beat that.
that's the sort of the caveat to it, is that you can only use data that comes from the medical source. So one of the reasons why this is possible is you're now getting a lot of attribute data that goes along with that coordinate. So if you've got a medical record that gives, symptomology, it's also got some basic information about the individual, you could certainly run point pattern analysis, but also you could run potentially some more causative types of analyses as well based on these other attributes. What you cannot do is use any other external data at this point. So you couldn't use sensors, you couldn't use road networks, because they could be re-engineered back and find out exactly where you are. So it is just the coordinates of the medical records, for example, that you're using. Yeah.
Any exploration of animal disease vector data gathering, such as sticking something on a cat or a rat?
No, it sounds cool, and anything that's cool, I'll go for. We have done quite a lot of vector work using this. So mosquito vector work, we've got study in Colombia, which has been going for 3 or 4 years, where we have had mosquito control, talking about different neighborhoods and what's going on in these neighborhoods. And that's now expanding out into sort of violence in these areas. Violence, I didn't talk about it, but Haiti, our project is shut down in Haiti at the moment for about 6 months because of gang violence. But in Colombia, obviously, there's a lot of violence there as well. And what is the impact on mosquito-borne disease in association with violence? In this country, and I've been talking about this actually to a couple of people, a similarity in Phoenix to work I did in El Paso was that because you have these sort of severe but brief rain events, you have mosquito problems associated with those. I mean, you wouldn't think it in the desert, but you have mosquito problems. And so talking to mosquito control, you can use these approaches to actually get the institutional knowledge of which species do they find in which locations, what approaches they use. This type of institutional knowledge is really important, especially when those individuals move on, retire, or whatever else. Instead of then going back to square one in terms of a learning curve, it's a way to start to build up an institutional knowledge, year by year of what is happening to mosquito populations. So. But yeah, I love the idea of sticking these on animals as well.
Thank you very much, Andrew. Before we thank our speaker, a couple of final housekeeping notes. A reminder that this is just the first of many colloquia we'll have this semester. You've set a very high bar for us. Thank you. Almost every Tuesday at 3 p.m. we'll gather in this room. Next week we will remain in the health domain and think a little bit about the intersections between climate and health. Bob Davis from the University of Virginia, who is in the room today, will be our speaker next week, and we look forward to that. But Andrew, I think you've left us inspired and energized, not only by your research portfolio, but by the different ways you're engaging students, and your public impact has been particularly impressive to learn about. Thank you very much for joining us.
Thank you. Much appreciated. Thank you.